Welcome, our listeners or audience, and good morning to you. We are here also with you again today to look at some questions or problems drawn from mathematics, where we are tested on being able to get a value of unknown that makes a certain expression or expressions a complete square or a perfect square. Categorically, this topic is found in mathematics under quadratic equation. So what we are going to do is to make the understanding clearer and make what we are saying very clearer. We are going to draw some questions and place on the board and solve with you in a way and manner that is not going to leave you in doubt anywhere, understanding completely the steps required in obtaining the value of unknown that makes a given expression or expressions a complete square or a perfect square. Therefore, we encourage you to give in your attention as we go about it with you. Remember to subscribe to our YouTube channel so that the moment we upload what a class in form of what a video, you definitely get a notification. So if you subscribe, then you turn on your notification what bell. Thank you very much. The first question says, and I write. So first question says, what is the value of Q? What is the value of what Q? That makes the expression 4x raised to power 2 plus 5 what x plus what q a complete square or a perfect square. For us to be able to answer this question correctly, two things are involved. Number one, we return back to the expression given to us and examine it and know the type of expression given to us. Is it a linear expression? Is it a quadratic expression? Is it a polynomial expression where the power of the unknown is more than 2? So we come back here. The unknown here is what is x, and the highest power of this x is what is 2. If you check the terms involved in this expression, they are 1, 2, 3. These two characteristics are pointer that this expression is a quadratic expression. And because it's a quadratic expression, the first thing you need to do for yourself is to be able to recall what we call the quadratic expression or what we call the quadratic equation. And what do I mean by this? The general quadratic expression and the general quadratic equation. The general quadratic expression is written like this. So as a way of solution to solving this problem, permit me to divide this board this way. So as a way of solving this, I have solution. The general quadratic expression is given as, we have what? A x raised to power 2 plus b what? X plus c. Okay? Now, if you now agree with us that this is a general quadratic expression, we are going to match it with this. Because this general quadratic expression contains 3 constants here. One is a constant, which stands all alone. But then the coefficient of x here, b, is also a constant. And the coefficient of x raised to power 2, a, here is what? Also a constant. So we have the variables here. What? The first one is what? Is a. Matching this a with this, of course, our a is what? Is 4. So I have that here is what? 4, comma. Matching this with this, we have that our b here is what? 5. So b is equals what? 5. And matching this c with this, we find out that our c is equals what? Q. So having written the quadratic expression, we were able now to know the values of a, b, and c with the expression given to us. The next thing is now to recall for us what we call the general quadratic formula. The general quadratic formula is given as x raised to power 2, or is given as what? X is given as plus minus b, what we call minus b, plus minus general square root of b raised to power 2 minus 4ac all over 2a. This is what we call the general quadratic formula. Now, at times, if you go to some textbook, this formula will be written this way with some kind of definition. They will say that our x is given as minus b plus minus general square root of what? D all over 2a. They will ask you, they will tell you where this d is called the determinant of the quadratic expression. Where this d, where our D is determinant of the quadratic expression. And one thing or two things are very important here. One of which is, whenever this determinant D, which of course in these two equations, you know that this R D is given as b raised to power 2 minus 4ac. Whenever this D becomes what? 0, two things happen to the quadratic expression. Number one, the quadratic expression becomes what? A perfect square or a complete square. And number two, the quadratic expression is the one that is going to have two equal roots. These are the two conditions when this D becomes what? 0. And of course, you know that when this D becomes 0, we have that D is equals 0. And you know that our D is b squared minus 4ac. So I have what? That b squared minus 4ac should now be equal to what? 0. And of course, this one can come over there, and we have that b raised to power 2 becomes 4ac. By taking this 4ac over to the other side of what? Of the equation. With this, we can then go ahead. We now return back to what we wrote here. Do you remember that our a is what? Is 4. Do you remember that our b is what? Is 5. So in place of b, I'll write 5, which is 5 raised to power 2 equals. Here I have 4, then I multiply by 4. So here is my a. My a here is also what? 4. This 4 is coming from this equation or this expression. Here is my 4. Here is a, and a is 4. So I'll say multiply by 4. My c here is what? Is q. So I'll put what? Q then. So I will now come here. Of course, 5 raised to power 2 will give me what? 25. This equals 4 times 4 will give me what? 16. So it becomes 16 what? Q. For me to make this q to stand all alone, I'm going to divide both sides with the coefficient of q, which is 16. So I have all over 16, all over 16. So that 16 can cancel 16, and what is left becomes what? Q. And this q now is given as a 25 all over 16, which can be reduced to mixed what? Number. So the value of this q that makes this expression a complete square or a perfect square is 25 over what? Over 16. As a word of recap, what did we do here? What we did here is that we are given an expression and we are told to find the value of q, which is unknown here. This value of q here is not known. Okay? That we are told to find the value of this word q. And this q, of course, in a general quadratic expression is the constant. Okay? Just that here, this constant q, we don't know its true value. Whether it's going to be 1, whether it's going to be 0, whether it's going to be 2. It is on that ground that we are calling it unknown here. Because in the real sense of it, the unknown that is required in this quadratic expression is what? Is x. So we first of all examine the expression that was given to us, and we concluded that it's a quadratic expression. Because the highest power of the unknown is what? Is 2. Because the quadratic expression, we quickly wrote the general quadratic expression, which is given as this. Then we now begin to match each terms of the general quadratic expression with the terms of the expression given to us. Here is my ax raised to power 2. I match it with this to find out that the value of my a is what? 4. I equally match this with this to find out the value of my b is what? Is 5. And I matched this with this, so the value of my c is what? Is q. Then I now record for us what we call the general quadratic formula, which is given as this, which in some textbook you see them write it this way, and they will give this additional information, that this d is the determinant of the quadratic expression. And it is said that when this d becomes what? Zero, there are two things that happen to the quadratic what? Expression. Number one, that the quadratic expression now is a type that is going to have what? Two equal roots. And number two, that the quadratic expression where this RD becomes zero is going to be what we call a complete, is going to make the expression a complete square. So because of that, we now say, okay, D equals zero makes the expression a complete square. And we know that this our D is B square minus 4AC equal to this zero here and this zero here. Taking this first C, AC over there, we have that B square is what? 4AC. Okay? So we now say, let us now substitute the value of this into here. My B is 5, I put 5 here, square it equals. My A is 4, look at my 4. Sorry, 4 is here, look at the 4. My A is 4, look at the 4 here, multiply by, my C is Q, my C is Q. Then we now multiplied out, made Q result of formula and arrive at this. So this is the value of D that makes that expression a complete square. Thank you very much for your audience. We really believe that you followed us now as we did profile solutions to that. Let us quickly take another example to make this knowledge strong. So permit me to clean this. Let me take also another number. That number says, and I write. Okay? They say find the value of k. The value of k that makes the expression 9x squared, 9x squared minus 12x plus k a complete square. A complete square. So what we are going to do first of all is, without wasting time, the highest power of the unknown here is 2, so it's a quadratic expression. Then we write the general quadratic expression quickly, which of course we have as a way of solution. We have that a x raised to power 2 plus b what? X plus c. So because of this, my a is 9, a equals what? 9. My b is minus 12, and my c is k. I'll quickly write out my general quadratic equation or formula, which says that my x is minus what? B plus minus square root of what? Of b squared minus 4ac all over 2a. Okay? Then I go inside what is here. That my b squared minus 4a what? C is equals 0 for me to find the value of k that makes this expression a complete square. So in that case, therefore, my b squared is equals what? 4ac by bringing this one over here. What is my b here? My b is minus 12. So I have minus what? 12 minus what? 12 all raised to power what? 2 equals. Here is my 4. I have 4 multiplied by. My a is what? 9. I have 9 multiplied by. And then my c is k. Is what? K. Of course, we know that minus 12 raised to power 2 will give us 144. This is equals. I have what? 4 multiplied by what? 9 multiplied by what? K. My interest is to make k to stand all alone. So I'll make k subject of the formula here. So I will now have, therefore, that my what? My k alone becomes what? 144 all over. We have what? 4 times what? 9. If you pick up your calculator and you go into this, you now find out that the answer comes out quickly, and then this value of this k make this expression a complete square. No, so that is how it goes over there. Okay, so thank you very much for your audience thus far. We equally believe that we left you with some knowledge about making expression a complete square or a perfect square. Thank you for your audience.